All right, here we go. Unit 8, Lesson 2. We're going to look at analyzing arithmetic sequences and series. So if we, again, in an arithmetic sequence, the difference is constant. So the difference between terms is constant. Difference between terms is constant. So let's do an example, or I'll show you what that means. So if I look at the sequence -4, 1, 6, 11, 16, ... Again, what I would look at is, okay, I'd say, what's the difference between the second term and the first term? So the difference here is 5. What's the difference between the third term and the second term? The difference is 5. The difference is 5. The difference is 5. So this is an arithmetic sequence. So yes, arithmetic. Whereas if we looked at a separate example, let's say we had the sequence 3, 5, 9, 15, 23, and I try to compare the difference is 2, the difference is 4, the difference is 6, the difference is 8. These are all changing. My differences are changing, so this would not be arithmetic. So we've got some rules. The nth term of an arithmetic sequence with the first term of A1 and a common difference is given by this. So again, if you needed to analyze it or come up with a rule, you can kind of use this. So if we look at this example, the nth term of an arithmetic sequence with a first term of 2 and a common difference of 3. So common difference is when you all have 5, 5, 5 like this. So I'm going to take my equation and say, all right, 2, the first term is 2, plus n minus 1 multiplied by 3, which after you distribute and combine like terms, again, this goes into both. So you get 3n minus 3, and then you combine 2 minus 3, you get -1 plus 3n. So we'll do one more example like that. Let's say we have the sequence of 4, 9, 14, and 19, and I need to find the rule or the equation. So again, my first step, make sure that they are all the same, which they are. So now I can say, all right, my equation A sub n is A1 plus n minus 1d. So if I plug in my first term, which is 4, my nth term, which again, I forgot, it goes on forever. And then my d, again, my d is 5, n minus 1 multiplied by 5. Let's distribute that. 4 plus 5n minus 5. I've got like terms here, so it's very similar, -1 plus 5n. A sub n. Slightly different type of example. Let's say I give you an arithmetic, or I want you to figure out the rule, and all I give you is one term is A sub 19 equals 48, and the common difference is D equals 3. So again, just writing a general rule, I know that A sub 19 equals, I don't know what my first term is, that's kind of what I want to figure out, but my n in this case is 19 and minus 1, and then my d is 3. So again, as I start to simplify, 19 minus 1 is 3, 18 times 3, 18 times 3 gives me 54. And I actually do know that because it tells me right here, a sub 19 equals 48 equals 48. So I'm going to subtract 54 on both sides and get negative 6 equals a sub 1. So now I have enough to plug into my true equation. A sub n equals a1 plus n minus 1 times d. A sub n, a1 we just found is negative 6 plus n minus 1, and d is 3. So a sub n equals negative 6 plus, we got to distribute, 3n minus 3. Negative 6 minus 3 is negative 9 plus 3n. So a sub n equals negative 9 plus 3n. If I'm only given two terms, so let's say that we're given two terms and I need to come up with a rule. So I might give you a sub 8 equals 21 and a sub 27 equals 97. Find a rule for the nth term. So we're going to kind of plug it into both of our equations. So we were going to try to find d. So if I look at a27 equals a1 plus 27 minus d. And I'm going to solve that, and then I'm also going to look at a sub 8 equals a1 plus 7d. Now we can plug in some things that we know. So we know that a sub 27 equals 97. And we know that a sub 8 equals 21. So what I'm going to do is I'm actually going to subtract these two equations. Now, again, remember that it's like this, so we have to subtract negative 21, negative a, which is nice because this ends up canceling out. 97 minus 21 is 76, and 27, or excuse me, I think I miswrote that. That should be a 2060. Oh, 27 minus 1 gives us 26. So let me rewrite this. So again, 27 minus 1 is 26. When I multiply it by d, I get 26d. So 26 minus 7 gives me 19d. And then when I divide by 19, I get 4 equals d. So that's enough to help me get started. I still don't have, I need a1 still. So again, the parts you need for your equation, you need to find your first term and you need your common difference. So I just found the first term. So now I can pick one of these two. I can pick one of these two and plug in my d to my equation. So I'm going to take the equation of 97 equals a1, again, n minus 1 d. N minus 1 d, which again, n minus 1 in this case, because n is 27, is going to give us 26. 26 times 4, 104. So 97 equals a1 plus 104. Subtract it from both sides, and you are left with negative 7 equals a1. So now I have my information that I can write the final system. I can say, all right, a sub n, this is my base formula. I'm going to say a sub n equals a1 is negative 7 plus n minus 1, and my common difference is 4. I'm going to distribute negative 7 plus 4, n minus 4, and negative 7 minus 4 equals negative 11 plus 4n. Last thing is we have the sum of a finite infinite series. Finite arithmetic series. And so this formula is given as, if you're trying to find the sum, you're going to take a1 plus a sub n and divide it by 2. Sn is the mean of the first and the nth terms multiplied by the number of terms. So again, you're trying to find the average, and then you multiply it by the number of terms. So if we take the summation of I equals 1 to the 20th term, and our equation is 3 plus 5i. So again, I'm going to identify my first term, which is 1. So a sub 1 equals 3 plus 5 times 1, which is going to give me 8. And then I'm going to identify my last term, which is 20, which is going to give me 103. I'm going to add the 2 up. So the sum of my 20 terms is 20 times 8 plus 103 divided by 2. 20 times 8 plus 103 divided by 2. Make sure you do what's in parentheses first. 111 divided by 2. And if you plug that into your calculator, you are going to get 1,110. So the sum of the 20 terms, the 20 term series is 1,110.